Okay, we're back here with our speaker, Hannah, after the first presentation of our spring semester of Exploring Science. And we were really excited to see everyone again tonight. And we are going to, so we had so many great questions from all of you. We're actually going to do a follow-up with Hannah by popular demand. So I'll start off with one of the questions by combining a couple that I thought were really interesting. So, Hannah, what if we just put UV lights directed at solar panels when the sun goes down? Or do solar panels, are they affected by UV lights? Can you talk to us a little bit about that?
I'm certainly not an expert in solar panels, but the first problem that I see with that is, well, you have to power the UV light somehow, right? So maybe you could use that solar panel to power the UV light, but then it's just kind of a circle of energy and you're not getting anywhere. So um, I'm guessing that the UV light, yes, it would affect the solar panels depending on the wavelength that the solar panel absorbs, but you would have a problem because you need to power that UV light.
I see. So you're sort of powering something to power something else, and you're not really creating anything or harnessing. That's really the beauty of solar power, right? Is that you're taking something that's already out there, the sun, and grabbing onto that, as opposed to generating something yourself. Cool. Ellie, did you have a question?
Yeah, sure. I had two questions, Hannah. Um, so I feel like they could maybe be related, but I'm a little unsure. So somebody asked, what if you could turn heat into electricity? And I was wondering if any of the methods that you talked about already involved that, or if there were any other ways that you could turn heat produced from your solar cell into electricity.
Yeah, that's a great question. And, you can kind of turn heat into electric energy because that's how turbines work. You heat water and the steam turns a turbine and that creates electricity. But it would be complicated with something like a fuel cell, which is pretty small, and the heat that it's creating wouldn't really be enough heat that you could do something like that with it. That heat would really be lost to the atmosphere and hard to harness.
Another question is, so if a big effect of climate change is that we're heating up our atmosphere, if something happened all at once that produced a lot of heat, like a nuclear explosion or something big and catastrophic like that, would the heat from that be able to increase the rate of climate change?
Um, well, the first thing that you have to consider is this is on such a huge scale that it's so hard to contemplate. But really big events like volcano eruptions and other things that put just a ton of these greenhouse gases in the atmosphere do actually have a significant effect on the amount of greenhouse gases in the atmosphere because it's so much gas all at once. But even then, it's a pretty small amount relative to the amount that we're pouring in regularly with things like cars and planes.
Okay. So even huge things happening are completely outweighed by our everyday usage of carbon fuels. Okay, thank you.
Exactly.
Okay.
Yeah, I can ask my question. So my question was about the CO2 that we're producing. And so if we're producing all this CO2 in the atmosphere, isn't it just really a feast for all the plants to take up the CO2?
Yeah, I mean, technically it is. And that's the beauty of how the Earth was created. It was created in this cycle where we produce CO2 and the plants use it as food. And the problem is we created all these kinds of technology that put way too much CO2 into the atmosphere so that the plants can't handle it and they can't take that much CO2 out. Now, one way to fight climate change is to plant more trees because that is removing CO2 from the atmosphere. But it's such a huge problem of a huge scale. You'd need to plant an enormous number of trees in order to really make a difference.
Cool, thank you. You answered my follow-up question as well.
Cool.
Awesome. I've got one more question for you as well. So I think this question came from a student who was looking at the reaction that you were drawing about carbon during combustion. And so as a lot of reactions, you can see them going in the opposite direction as well. So if we can make carbon, can we do the exact same thing in the reverse?
Yeah, that's a great question and something that scientists are working on a lot today. It's called carbon sequestration, where we take carbon dioxide from the atmosphere and we use it to create something useful. And it's a huge part of research, but the problem is it's really hard to do. It's really hard to do it in a way that's useful to us, and it requires a lot of energy. So you would have to use some kind of alternative energy source for it to really make a difference. Because if you're burning CO2 just to take CO2 out of the atmosphere, it does close the carbon cycle, so you're not necessarily making new CO2. But if you really want to take it out of the atmosphere, gets a little complicated.
I see. That makes a lot of sense. Cool. And Eli, do you want to round us out?
Sure. I have two questions for you, Hannah. The first one is, you mentioned that water is a byproduct of these fuel cells. Where does that water go?
Yeah, so it leaves the fuel cell and would make its way kind of out of the car like an exhaust pipe, like your exhaust would come out of your car in an exhaust pipe, because it's probably hot enough in there that it would be about water vapor and not water liquid. And that would just make its way out of the car, just like cars are built today to have an exhaust pipe.
Nice. Okay. And my second question was, you mentioned how, it might be dangerous for fuel cell cars to be on the road because the hydrogen might, explode if they get into a crash. Why don't we just make fuel cells on our homes? Because, houses don't normally crash into each other.
Yeah, that's a really good point. And people are doing that. There are actually several homes out there in the world that are powered by fuel cells. But a couple of the other problems that we talked about do come up. It's really expensive because those fuel cell catalysts cost so much, and they're not super efficient. So you have to have extra fuel cells to get all the energy that you need to power your home.
No, I'm just going to say that I'm assuming it, takes a lot more energy to power a house than it does a car.
Definitely. Yeah, we use a lot of energy to power our homes.
When you show the process of which the fuel cells work, that you said that there is a loss of heat, which does not convert to electric current. Is there any way to work around that or to recycle the energy loss to?
I guess it depends on what you're using your fuel cell for. Some people, when they have their fuel cell powering their house, they use the heat that the fuel cell creates to heat their house. So you're using the energy in that way. But we don't currently, that I know of, have a way to take that heat and reharness it into electrical energy. You can just use that heat to heat something if you want to heat something, either your house or maybe the water that you use to shower.
Awesome. Well, thank you so much, Hannah, for answering our questions. Did you have any closing thoughts for our students?
Just to get involved in being active and trying to help the environment. It's probably the most important problem that we're facing in the future. And I encourage everyone to do whatever they can to help solve it.
Cool. Thanks a lot. And we'll see you all next time.
Bye, guys. It was great to see you.
Bye. Thanks for the talk.